Good evening, class. Yeah, good evening. Ojo, can you hear me?
Good evening, sir.
Yeah, evening. Good. Okay. Yeah. Your colleagues are late for class. Let's begin.
Okay.
Yeah, so you're welcome to Math202 Engineering Statistics. Okay, so like the name sounds, we are talking about statistics relevant to us as engineers. Okay, and before we go into the course, it will be relevant we look at the course outline to see the materials we need and the topics we're going to treat within these 16 weeks, or let's say 8 weeks, since we are meeting twice every week. Okay, so this 8 weeks of studies. Very well. Yeah, so um, so we can see the course outline. Okay, and like I sent to you earlier, okay, you'll notice that the course basically covers the concept of probability and statistical methods, which is required by scientists. Okay, the statistical section will both look at descriptive the statistical portion of the course will be looking at the descriptive and inferential methods, okay, of describing data. Then we also talk about probability distributions, okay, of random variables, their properties, and how relevant these distributions are toward inferential analysis. Okay, and for the aspect of inferential techniques, we'll also be looking at various analytical tools, okay, beginning from estimations, okay, where we look at point interval estimation. We'll also be looking at various inferential tools, hypothesis testing. Okay, we'll look at chi-square. We'll be looking at the test of one mean, test of two means. We'll be looking at test of more than two means. Okay, using analysis of variation. We'll be looking at various other analytical methods. Okay, then we advance to other topics like exploratory design analysis, okay, where we bring all the various techniques, graphical techniques available, okay, for exploring data, okay, as against classical methods, which we would have already looked at. Then we'll finally rest on statistical quality control, okay, measures. Okay, so that is what this course is basically going to talk about. So at the end of the course, we should be able to, okay, apply various probability theories to problems. Okay, so looking at problems like epidemiological studies. We want to find the probability that somebody will get infected. We should be able to know the behavior of the process, okay? So we can apply the appropriate probability distribution for prediction purposes. Good. So we should also be able to, identify which statistical tools are relevant for which kind of analysis, okay? Given an engineering problem or given engineering data, which analysis tool do we apply at a point in time? Okay, then when we go into the engineering field, okay, in the industry, okay, where we are very interested in quality of products that are produced, okay, we should be able to understand the concept of quality control and how they applied at various in various engineering or production companies. Very good. Now we'll go to the key reference text. Okay. We're going to use Probability for Engineers and Scientists by Wadpole, Myers, and Myers. Okay, so try and download the book. It's online. It's available online, so try and download it for use. Montgomery 2 is available. We have a number of these books online, so you can just search for them. Some you have to buy, others are free online, so you can access them. Okay. Then we next want to look at the course schedule or the topics for each week, the weekly topics. I want the game. Okay, so we have the various topics. Today we are supposed to be looking at an introduction to statistical concept, where we look at the types of data and the scales of measurement of data. Okay, and when you go to LIMAS, the corresponding note is lesson note 1.1.1. Okay, so kindly check on LIMAS for your notes. Okay, make sure you check on LIMAS for your notes, because all the notes are available on LIMAS. If you're having a problem downloading it, contact the IT unit, let them assist you. Then in our next class, which will be on Wednesday, we'll be looking at descriptive analysis, okay, or better still, descriptive statistics, okay, where we're looking at data distributions, measures of central tendency. We'll be looking at measures of variability, how to estimate them, okay, and then once again, there are corresponding notes to that on LIMAS, okay. But as well, I'll be sending you a link to some YouTube videos, okay, for you to watch. And you're also aware LIMAS Plus is also functional, okay, where we have a very large database on LIMAS Plus and LIMAS Plus Plus. Okay, so once they are functional, it will be very prudent or imperative for you to go there, okay, to have a look at some of those materials, because it will be very relevant for the course, for the understanding of this course. Okay, and subsequently we'll be looking at introduction to probability, random variables. Okay, we take 1 or 2 weeks for that, where we wrap up on special probability distributions. Then we begin with inferential statistics, okay, after we've covered sampling distribution. And we look at correlation, regression analysis, sampling distributions. We'll be looking at hypothesis testing. We'll look at test of one mean, its application, test of two means, its application, okay, interval estimation, point estimations. We'll look at the chi-square goodness of fit tests. Okay, we look at the chi-square independent test and its application in real life. We'll also be looking at analysis of variation, the application as exploratory design analysis. Okay, exploratory design analysis. Okay, let me correct this here. So we have exploratory design analysis. Okay, as you have it in your notes on Limas. Okay, good. Then finally, like we said, we'll wrap up on statistical quality control. Very well. So evaluation of the course, as you're aware, we use mid-semester, end of semester class attendance, class participation, and then coursework. Okay, participation will be based on the forums that will be posted on Google Class. So then your attendance to will be monitoring in class, and coursework, I'll post them on Limas, so watch out for it. Okay, May semester is going to be the normal open book exams and end of semester exams as well. Okay, on that note, let me also say that our WhatsApp platform too is for communication. Okay, so if you have any questions, you can post it out there, out of the online class. And if you also want to reach me personally like you did in the main school, you can also contact me still on my WhatsApp line. Okay, personally, I'll get back to you. Okay, so you all required to submit all assignments before the deadline. Okay, please again, if you don't submit your assignment before a deadline, I will not reopen it for you. Okay, so you take note of that. Whatever challenge you have, make sure you submit your assignment before the deadline. Okay, good. So take note of that so you don't make work complicated in class. Let's see. Yeah, I think you are very familiar with this academic honesty. I want to stress on this again. Okay, make sure you do an independent work. Okay, try to do independent work for all assignments, for all forums, for all examinations. Okay, and then especially in the exams, don't forget to submit your plagiarism report. It's very, very important. Okay, very good. And you know the implications of this. Once you copy somebody's work, okay, you score 0 and that person will also score 0. So as much as possible, just avoid it. Avoid all forms of communications with your colleagues regarding your assignments, okay? So we don't get to that point. Try to do an independent work. Very well. Now, some of you think once you are out there, nobody can see what you are doing. Okay, then it's a way of being smart and beating the system. But you see, beating the system will only amount to questions being raised about the quality of your certificate in the end. So let's all try to do a good work so that when somebody comes with questions about the online process, we can confidently defend that our students did an independent work. Okay, so try and have that at the back of your mind and avoid all forms of copying. Let's help ourselves to make your certificates, okay, worthy. We have already obtained our certificates, but if you disrupt this whole process of the online, teaching, it's going to affect you big time. Okay, so try to keep that at mind whenever you are working and do an independent work so that we as a university can also defend you in the long run. Okay. Yeah, so these are the key things we need to know. I've sent you the course outline already, so read the details and you'll be just fine for the course. And the outline too, like a lot of you do, once you are given the outline, you put it somewhere because it's not part of your notes, okay? The outline is supposed to guide you to read before you come to class. That is why you have the reference materials, the reference text over there. And you also have the notes attached to each topic. So you go to your notes, read. You go to the reference text, you read. I'll even be posting you links to YouTube videos where you can watch a lecture on or a tutorial on a topic I'm about to teach before you come to class, so you can understand the topic better, okay? So be guided by the course outline for the course. Okay. Yeah. So engineering starts, like we've already said, okay. Statistics is very relevant to us as engineers, okay, especially we engineers take a lot of data to make decisions for redesigning processes, okay, or even designing a new process. We need data for decision making, okay, and the only means by which we can make optimal use of data to make decision is through what? Statistical concept and theories, okay, and that is why we need to go through this course. It's going to be very relevant for you as an engineer on the field. Very well. So the question is, what then is statistics? Statistics is a science, okay, of collecting, organizing, presenting, analysis, and interpreting data to assist in making effective decisions. Okay, so if we say that is a science, then we are talking about a systematic process. Okay, a systematic process involving 5 stages, okay, which are the collection of data. We first need to collect data, organize the data, present the data in an informative way, okay, further proceed to conduct analysis, and then make inferences, okay, from this analysis on the population to assist what? Make effective decision. Okay, now I'm going to play a video. I want you to give me feedback if the sound is very clear. I'm just replaying the previous lecture, okay, for this same course. Okay. Okay. Here is then the last day of the script. Okay, so what I'm saying here is the first statistics is in 5 folds. Please, can you hear the volume? Was the volume clear enough?
Yes, sir. Yes.
Okay,
Yes.
good. Very well. Okay, let's continue then.
Collecting, organizing, presenting data, analysis, and interpreting your results for decision making. Now, the first thing that data collection, organizing, and presentation fall under descriptive statistics, whereas analysis and interpretation of results fall under inferential statistics. Okay, so that is what it's saying. So collection is going out there with several data collection tools to take data. Organizing is where you are creating the data, putting the data together, okay, to establish or to form what we call as frequency distribution tables. And presentation, we use bar graph, pie charts, graphical techniques, okay, graphical techniques to display the data in various categories for us to really get what is going on, okay, good. Then we have inferential techniques, which make use of a number of statistical analysis tools, okay, where we go further to test the obtained data from the field or from an experiment with underlying theories or what is expected, okay? Then based on that, we come to a conclusion and we interpret our results, okay, in light of what we are observing from our sample information. Good. Now, key things we need to understand before we proceed with any statistics course is the concept of a population and a sample. A population is a complete set of individuals or objects with a particular characteristic of interest, okay? Whereas a sample is a part of the population of interest, okay? So we may be interested in examining, maybe in a research, we are interested in examining the leadership of head principals, okay? Leadership at the senior high school level. If we're talking about leadership or, the type of leadership, okay? Then the key people we're talking about here will be the headmasters and headmasters or assistant headmasters. They are the leaders in the senior high. So that will be our population. Every headmaster or assistant headmaster will have that particular characteristic. So the list of all head teachers are what we refer to as our population. But if we should select, currently we have about 700 senior schools. So if we were to select about 200 head teachers in a study, then we've selected a sample, okay? Sample for our study. Good. Now to today's lecture, which is your lecture 1, types of data. Very good. Now, the type of data we have is dependent or contingent on the type of variable at hand. Okay. Then what do we mean by variable? A variable is a criterion, a quality or a characteristic which value changes from one object to the. So an example of such a quality is the age of persons. So in, let's say, our research on the head teachers, when I administer the questionnaire, I'll have question 1 as what? Age. Okay, so question 1 is age. Then I give a number of responses, maybe 25 to 30. Put our square bracket here. We have 31 to 35. Let's put something like that. Okay. Then we have 36 and above. Okay, or we can say greater than what? Greater than 36. Okay. So age is a characteristic of interest to us as a researcher. So age is your variable. Good. So our variable is what? Age. Good. Another example, I could ask the person, how long have you worked? How long have you worked? Or how long have you been in that role as a head teacher? Okay, then I say less than 1 year. Okay, 1 to maybe 3 years, and then above 3 years. Okay, good. Now, when I do that, my variable of interest is what? Is you can say experience, or experience in the school, or time spent as head teacher. Okay, so your variable will be the time. You are measuring the time, okay, as head teacher or as leader. Okay, so as the head, that is your variable. That is what you are measuring. Okay, now if let's assume this is the first questionnaire we administer to head teacher from a school, one head teacher from a school A. So head teacher from school A would have told us he's above 36 years and he's been in the school for more than 3 years. Okay, so what is going to happen is, when we come to, you see, this is data collection stage. All that we are doing is data collection. When we finish with data collection, we now need to classify and group that data. Okay, so we come with the respondent, what IT students will call as a record. Okay, then we have the variables. The first one is age. The second one is what? Time spent. Okay, or if you like, you can put experience. Okay, good. So for the first head teacher from school A, that is respondent from school A, his age is what? 36 to above 36. Okay, good. So we could have chosen to write above 36 like that. Above 36. Good. Then experience is what? Above what? Above 3 years. Good. So this is for the first respondent. Now let's take the views of the respondent from school B. So we take head teacher from school B. He says is between 31 to 35. He's been there for 1 to 3 years, between 1 to 3 years. So we have B. We have 31 to 35. And then the person has been there 1 to 3 years. Yes, let's take more data. We want data from about 3 respondents. So let me take more data. So we take the next data. So in the next data, we're going to have this guy is also 31 to that, but he has just been transferred to the school. So he's been as a head teacher for just 1 year. So when we record this will be the test school C, and that will be 31 to 35. and then he's been there for 1 year. Good. So you will see that what we have just generated on our left bottom corner is what we usually refer to as what? Data, right? Are you with me? Yeah, Grafty.
Yes, sir.
Yeah, you have your hand up.
Yes, sir.
You have a question to ask? Okay. So, like I was explaining, this is what you refer to as what? Data. Yeah, Grafty, it appears you have something to say. Come in, I'm waiting.
Yes, sir. It was the other one I raised.
Okay, sure. So this is what we refer to as what? As data. Okay, this is what we refer to as what? As data. Okay, good. Now let's take some more variables. Okay, we are more. Let's say we were interested. We asked more than 2 questions. So another variable will be if you look at age, experience, then we can look at educational level. Okay, highest educational level. So we can say educational level, ed level. Let me put it that way. Highest educational level. Okay, so this guy could say degree. This guy could say I have a master's. Then the last person will say I also have a master's. Okay. Yeah, so we've built a database, okay, for this respondent. 3 people, we have database on these 3 individuals. Okay, so now I want to do something quick before we move on. That should have come at the end, but since I've already written this, we'll do that quick before we post. Now, there is a concept we refer to as coding. Coding means we are assigning numerical values to non-numeric data. Okay, so in the context of this study, we could code these variables. You see, if you say above 36, is it 36, 37? I mean, sorry, is it 37, 38, 39? You don't know, okay? But you can code it as 1 and inform the computer software that 1 means above 36 and above. And let's redo this because it's smaller.
We're not seeing the video, sir.
Okay, our initial responses.
Yeah, hello. Hello, audio.
We can't see the video. The video is not showing. The video of the
is it from beginning or just now?
Yes, from the beginning. From the beginning. We thought you are just talking, but we can the screen is not changing.
Hello, sir.
But
yeah, I'm back.
Me a long time ago.
Okay.
Yes, sir.
So let's continue with our activity.
Wow.
On a scale of 1 to 5,
okay.
Grafty, I want.
Yes, sir.
the coded form of the data.
You should have notified me a long time ago. It means we are starting the whole video again. Okay. Can you see it now?
Yes. Yes.
Okay, at least you were following the explanation. So, wow.
We'll catch up.
Okay.
Yes. Okay. So what is going to happen is when we come to, you see, this is data collection stage. All that we are doing is data collection. When we finish with data collection, we now need to classify and group that data. Okay. So we come with the respondent, what IT student will call as a record. Okay. Then we have the variables. The first one is age. The second one is what? Time spent. Okay, or if you like, you can put experience. Okay, good. So for the first head teacher from school A, that is respondent from school A. His age is what? 36 to above 36. Okay, good. So we could have chosen to write above 36 like that. Above 36. Good. Then experience is what? Above what? Above 3 years. Good. So this is for the first respondent. Now let's take the views of the respondent from school B. So we take head teacher from school B. He says is between 31 to 35. He's been there for 1 to 3 years, between 1 to 3 years. So we have B. We have 31 to 35. And then the person has been there 1 to 3 years. Yes, let's take more data. We want data from about 3 respondents. So let me take more data. So we take the next data. So in the next data, we're going to have this guy is also 31 to that, but he has just been transferred to the school. So he's been as a head teacher for just 1 year. So when we record this will be the test school C, and that will be 31 to 35. And then he's been there for 1 year. Good. So you will see that what we have just generated on our left bottom corner is what we usually refer to as what? Data, right? Are you with me? Yeah, Grafty.
Yes, sir.
Yeah, you have your hand up.
The other one I raised.
So another variable will be, if you look at age, experience, then we can look at educational level, okay? Highest educational level. So we can say educational level, ed level, let me put it that way, highest educational level. Okay, so this guy could say degree. This guy could say, I have a master's. Then the last person will say, I also have a master's. Okay. So, yeah, so we've built a database, okay, for this respondent. 3 people, we have database on these 3 individuals. Okay, so now I want to do something quick before we move on. That should have come at the end, but since I've already written this, we'll do that quick before we post. Now, there is a concept we refer to as coding. Coding means we are assigning numerical values to non-numeric data. Okay, so in the context of this study, we could code these variables. You see, if you say above 36, is it 36, 37? Is it 37, 38, 39? Which age? You don't know, okay? But you can code it as 1 and inform the computer software that 1 means above 36 and above. And let's redo this. Because it's a smaller age, okay, our initial responses was, I think we started from 26 to 31. So 26 to 39 will be coded as 1, whilst 31 to 35 will be coded as 2, and then 36 and above